Okay.
Hello, everyone. Welcome to the session of Pantopics, and I'm giving the floor to Nikhil to deliver an exciting use case and approach. The floor is yours, Nikhil.
Thank you, Ivan. Thanks a lot. Hello, everyone. Welcome to my talk. I would be presenting an interesting topic today, which is knowledge graph embeddings in the industry. So I'm originally working for Pantopics. We are based in Lindau. So I'm a knowledge engineer. So my responsibilities primarily rely around building data pipelines around knowledge graphs or so. So so we would be talking about some interesting use case, specifically one use case which is a bit mildly in depth, so which might be of reasonable interest to you to have a look, and maybe you could use these ideas for your own business problems. So we at Pantopics, we support our customers in optimizing their business processes, and we want to add maximum value to the data. We use knowledge graphs mainly. We want to have as much as sense from the data as possible and give best business solutions to our client. We obviously focus on the best methods possible, the best ideas, also trying to get as close to research as possible to get the best business outcomes for clients. So yeah, feel free to reach out to us during this time. So we have our booth, and you would find some things quite interesting around there. So it's a very exciting time at this time we are living in. So it's a lot of knowledge graphs. It's a lot of large language models. I think there's a lot of talks happening if knowledge graphs and large language models, how they are related to one another. And
Excuse me, Nikhil. Bob is mentioning he's not seeing the slides.
okay.
Do you mean
Just
to
a second.
share the presentation?
Yeah, sure. Yeah. Can you see the slides now? Yeah, perfect. All right. So primarily coming to the talk earlier. So it's an exciting time we are living in at this point. So we are at the heart of the growth of large language models. The topic largely evolves around how it's going to impact the knowledge graph industry. And I think along with the best ideas of machine learning and large language models, we could really help solve some very interesting industry problems, which I would get into some depth right now. So I have an experience of 4 years in this and worked on quite a lot of relevant topics. So I think getting the logic out of the data is one of the most important things we see. And we see that representation of technical data, technical documents, is very important. And we want to make the best out of this. We want to get the best meaning out of technical data. And knowledge graph really helps us with that. And there are different methods to analyze the semantic relations in this technical data, and there are different use cases we can solve using these things. So it would be interesting to have a look at this and adding a machine learning layer on top of it. And if you have heard of knowledge graph embeddings, and I think you have a good start for this talk. Primarily, we want to kind of integrate technical data into knowledge graphs. We want to have as much information as we can from technical documents inside a knowledge graph so that we have a semantic representation of all the technical documents, brochures, data sheets, everything we can get from a customer, which we can kind of analyze, retrieve, unify, and integrate into our system. This is one of the main challenges or main tasks we have at this point. So of course, we face a lot of challenges like incompleteness, correctness, and we also want to ensure that the data we extract from our clients, they make a lot of sense. And we are not interested of extracting data with absolutely zero meaning. We want to have as much semantic sense as possible. So knowledge graph is a great start for it. So the first thing, you want to represent technical data. You need an ontology. You want to model properties. You want to model different properties. For example, you have data sheets, your manuals, and your brochures, and other web sources of data, and you want to transform them into a knowledge graph. The first thing is you want to kind of model the properties of the different components of the machine, like you have the mass, dimensions, efficiency, etc. And all of these can be modeled in a knowledge graph. And that gives us a good start, a good skeleton to solve our problems. The transformation is one of the most important steps. We want to ensure that maximum amount of data is being transformed here. I would get into a bit of detail here at this point. Now, when we talk of a technical data, we have an example of a data sheet here. What do you see? We want to extract as much information from the data sheet as we can and put it into a knowledge graph. You see that when you look at a data sheet, there are some very interesting properties you want to extract here. You have, for example, the model, you have the serial number, you have the year, you have the voltage. All of these properties are actually modeled in a knowledge graph. Now, how do you do this? The data, what comes to you, might be structured, might be unstructured, might be semi-structured. When you look at this data, you want to kind of map individual properties. You have some information which is not complete. For example, you look at the year field, it's not really complete. How would you solve this problem? You can't directly ask a large language model to help you solve this problem, right? You need to give enough context. And the solution lies right in the data. We already have a knowledge graph. Why not use it? Why just always do prompt engineering on top of it? So we want to use the knowledge graph to solve the problems what you're seeing on the sheets here. So at this point, you also would like to see what you can do with the data sheet. You could build a QA component. You could visualize this information. How do you do this? So not everything can be obviously solved by large language models, right? You obviously want to make maximum out of the data. Now, the potential of this idea of knowledge graph embeddings, which is the main topic here, is that we can actually solve these problems using them. For example, you can extend and build a strong knowledge base, which means you can have complete information represented in a knowledge graph. You could also use this information in the knowledge graph to visualize. When you visualize, I would come to that later point in the talk, where you could actually see how you could visualize different points of the knowledge graph. And then you could have a complete knowledge graph, which you can use for question answering, which is one of the things we are working right now. So about the sort of an architecture, what I would be talking right now. Now, this information retrieval, as I said earlier, can be structured, can be unstructured. Now, how do you retrieve the document? This is where you have the large language models doing the job for you. You have a lot of OCR models. You have different LLM models which you can use to extract information from the data sheets. Now, as I said earlier, do they do the job completely? Perhaps not. They miss some information. Not every large language model is perfect. They don't extract every information from the technical documents. So you want to have the maximum you can from LLMs, and we do the rest. From there on, we do an XML mapping into the knowledge graph, and we build a knowledge base. Now we have a pretty good knowledge base with us at this point, which we can use to get information. Is this enough? Well, probably not. It's not sufficient yet. So what do we do to build a complete knowledge graph? You have a knowledge graph now. Now you can represent a knowledge graph with embeddings. The embeddings are representation of the nodes and the relations. And we can start kind of representing information in the knowledge graph embedded. And you have these numeric representation of the knowledge graph. The idea of embeddings typically comes from the idea of property graphs. You have so many graph ML algorithms. Like what's mentioned in the talks earlier, we want to minimize the gaps between knowledge graph and property graphs. We want to use the structure as much as possible to get information out. We wouldn't want to separate property graphs and knowledge graph when we already know that we can apply so many graph algorithms to it. So using these techniques, we can get into things like neighborhood prediction, classification, visualization, and so on. This largely helps us solve so many business problems. You would want to analyze technical data in much more detail, and you can use different visualization techniques to analyze data of your clients. And one of the best ways is using knowledge graph embeddings. and neighborhood prediction to predict some missing data. Now, I would get into some reasonable amount of depth here. Um, Now let's say we have a knowledge graph and we have two product variants. Let's say product variant one uses machine one and machine two, and each machine has a function one and function two with them. And the same you have product variant two, which is using machine three, but it's also having an overlapping function two. So can we compare these two product variants, right? That's how do you understand the importance that these two things are related semantically. It's making a lot of semantic sense. So the way you do it is an embedding. It kind of intuitively captures the structure of the whole node. So you know the information is being stored, and you can see the ancestry, you can see the hierarchy. You have so many interesting facts which are hidden within the knowledge graph. And now you have a representation of a product variant in the form of an embedding. I think once you have the embedding, there are multiple things at which you can solve the problem. And now, because you have kind of got into the depth of a particular node or a particular relation, you're kind of uncovering some interesting aspects of the knowledge graph. For example, you have product variant one and product variant two. Now, can we say that product variant 2 also might use machine 2? It's because, in a way, they are both performing the same function. So probably there was an information which was missing during the time you used large language models, which it failed to capture. Probably a field went missing. And at that point, using these graph ML algorithms, we can kind of infer a link between product variant 1, product variant 2, and machine 2. And hence, the knowledge graph and knowledge base is slowly getting more and more enhanced at this point. And this, in turn, actually helps us solve some very interesting problems. As I said, the missing information, what we're talking about, is now being extended. I think we know that visualizing information, technical information, can be fairly complex. At this point, I don't really have a diagram which I could show where we visualize technical documents, but what I have at this point is an example uh, of visualizing knowledge graph over a two-dimensional space. You might want to visualize different machines, different product variants in a two-dimensional space. You might want to have an idea how close a product variant is to another. And when you have an embedding representation, you could actually have more information captured in a graph, in a two-dimensional graph, and you could plot it and see how close one product variant is to another. And this is one of the very interesting use cases what we come across, that sometimes we have different documents and we want to see how similar these things are, especially when you want to build a dashboard for your client. You want to build more and more, you want to capture as much information as you can from your client. And at that point, using interesting dashboards which are powered by knowledge graph embedding is one very strong use case what we're using at this point. So that's one thing what we work on at Pantopics. We are trying to analyze different informations and visualize them and build good dashboards. And that is not just powered by LLMs, but also powered by knowledge graph embeddings. Okay, let's say that you want to now perform question answering over your technical documents. I think there are enormous amount of tools you see these days, right? I mean, you go on the internet, you see so many things. You see how can you perform question answering over technical documents, and there are like ample amount of techniques you come across. But when you have a knowledge graph, why not use the information from the knowledge graph to do question answering? And this is one of the main things. When you have complete knowledge graph, when you have your knowledge base completely populated with appropriate amount of information, we would like to use this information to perform question answering. And we would like to validate the answers we get from these questions over a knowledge graph. And we are currently at this point working on how do we use knowledge graph embeddings to validate information we get over over the LLMs. So we primarily they are fine-tuned over technical data, but once you get the answer, we can validate them over knowledge graph. So that's one more use case. So we get into the AI-driven workflow. I think primarily there's different points. The first thing is that you have to have a good ontological modeling done. You need to represent as much information as possible in a knowledge graph. You need to model properties, and this is so important going forward because you want to have enough semantic meaning to your data as possible. And from this point onwards, we get into the information retrieval. And this is where LLMs come into picture because you have so many interesting uh, algorithms or OCR models which you can use to retrieve information from technical documents. And this is where the LLMs come. But from here on, the embeddings kind of take over. And here we have the embedding layers where we are analyzing information from our clients of different technical documents. And then if an information is missing, then we get into extending the information using embeddings. Once your information is extended, you would want to semantically represent a complete data of your client. And this together is a pretty good AI-driven workflow. Contrary to previous methods, you have a lot of rule-based approaches, which is having mapping rules and etc. And then you have the Sparkle queries where you're analyzing information using Sparkle queries of your client. But with embeddings, you can perform better tasks. You can have better recommender systems and so on. And we already have linked data at this point, and having knowledge graph embeddings on top of it is a very interesting addition. You can connect different knowledge graphs, different ontologies on top of other using knowledge graph embeddings. So this is one more use case we are working on. There are plenty of models. We can get into the depths of it. We have it's still a very interesting topic in the research. What we come across, you have algorithms like TransZ, Rotati, and CompGCN. In a sense, what's happening here is that you're representing information of a node in a space, and you're trying to kind of find relation between subject, predicate, and object. And we're trying to kind of represent this in an embedding space and try to solve the issues like missing links and so on. So this is a very interesting topic of research, and we are trying to bring these ideas together. So I think it was quite a short one, but I would kind of get into some interesting things here. So I think the first thing is that you have, when you retrieve information using the LLMs, you always have information which is incomplete. So the pipeline, what we use here at Pantopics, it helps us kind of have complete information represented from our client. And we are using the best AI methods possible to represent information. And this is one really big takeaway. So trying to bring in the best AI implementations into our pipelines. I think that training the model is one big bottleneck we face. We have to always work on having the best training pipelines, and we need to periodically train because you know that we work on data which changes periodically. And whenever a knowledge graph changes, we need to ensure that we are training at the right time and capturing all the information which is up to date with our client. And I think we are currently trying to build a good infrastructure to fine tune our models to represent technical data which is up to date on time. And this is one of the main bottlenecks we face. And we have different ML clusters we can use for these tasks. I think a chatbot plainly coming from LLMs is of course one important use case, but driven by knowledge graph embedding would be one more very interesting extensions to this idea. And that is something also we are working at this point to build chatbots over different technical data to our client, and then using embeddings to kind of validate the answers we get from there. Yeah, so this would be some of the sources. we would be working, which we cited here, and which are currently used in industry. So yeah, and it's an interesting topic on the whole, and I would be quite excited to talk about this. So thanks a lot.
Thanks a lot, Nikhil. We're starting to have some questions. Richard is asking, what role does AmpliGraph by Accenture play in your workflow?
No, Richard, that good question. Actually, that one was just one of the use cases we cited. What we do, we don't use any AmpliGraph in our pipeline at this point. We are directly using ML methods, and we don't really use it in our pipeline at this point.
Another one from Frank asking a simple question. Does embedding equal vectorizing?
Yeah, essentially, yes. I mean, you're having a vector representation of your knowledge graph, just like you have for from the GPT-4, but this is specifically for the knowledge graph and the semantics of the knowledge graph, which is being represented.
I I have a question for you. Do the ML algorithms that you showed are they custom developed for a particular use case, or they're generic and repeatable?
So they are at this point not general and repeatable directly, but the algorithms per se can work for different customers, but they have individual bottlenecks like the graph completion, etc. But for our use case, for our pipeline, it's custom at this point.
Any other questions? Please feel free to post in the chat. So I thoroughly congratulate you on a great session.
So we have a question from Bob. So sometimes we use the word model to refer to structure of our data described in the RDF schema. So yeah, so when I say model, I essentially was talking about a machine learning model in that sense. So it was not really, I'm not referring to the RDF model, so maybe there was a bit of confusion there. So a model from the RDF, you're describing this semantic model, what is being built in the first stage, what I spoke about, that's the ontology modeling. An ML model per se is something from the point of view of machine learning and deep learning, what you're talking about. And that is the models you train on top of a knowledge graph.
Thank you. Naso congratulates you on a great combination between LLMs and information extraction and graph embeddings for link prediction. And his question is, how do you link the entities from the documents to the entities in the graph?
Oh, that's a very good question, actually. So, I mean, so from purely from a research point of view, it's one of the things which is being worked on, and what we do is we are trying to learn a pattern between a knowledge graph embedding and an embedding you get from the document. And then we are trying to learn a similarity metric there where we could map the information from the knowledge graph directly to an embedding we got from the OCR. So we have actually we have a new question from Nicole. So LLMs at this point we have used GPT-3, 3.5, and we have only primarily worked on this at this point. We haven't tried the other models, and that's when I'm talking about the large language models. Yes, and with respect to the knowledge graph embeddings, we use ComGCN.
What were the main issues you faced when you were applying these machine learning algorithms?
So the issues what you have normally is the knowledge graph has a lot of information, right? So when you're talking about knowledge graph, you often have things like literals, which is not easy to to represent in terms of embeddings, because that can sometimes you have efficiency like 300 and 400 or so on. So they cannot be directly represented. So we had issues with literals, we had issues with graph completion, we had issues with some schema properties and so on.
Seth is asking, are the documents ingested into the vector space? Does metadata simply become more signals for the LLM?
I'm not sure I got that second part completely.
Does the
But
metadata simply become more signals for the large language model?
well, I think we are projecting the information from the documents into the vector space. So yeah, the first part is that, and I didn't get the second one actually. Okay. So what's your favorite embeddings infrastructure? We use Milvus at this point for our tasks, and they are quite powerful. And can you tell? And a bit more about LLMs, mappings between LLMs versus KGs. I mean, that's what we are trying to combine these two. But when you say LLMs, we want to ensure that LLMs are not fed anything. We want to feed semantic information, and we want to bring the semantics and large language models together.
Lane is asking, would QUDT or OM ontologies fit into your workflow? Quantities, units, dimensions, data types, or ontology of units of measurement?
So when you say ontology, I mean the data from these measurements. Of course, they fit into the methods we're using. But the schema per se, that's a specific semantic knowledge graph property. We are not actually feeding that to an ML model. But yeah, to answer your question, yes. Any questions?
If there are no more questions, we can stop the session and give you 2 minutes before the next one.
Sure.
So thanks everyone for being with us.
You.
Thank you, Nikhil. Been a
Thanks
great
a lot.
presentation.
Thanks a lot. See you.
Thank you. Bye.
Bye.